Good afternoon. In today's session, I would like to discuss about the curve representation in the computer graphics. In the computers, we can represent curve by coordinate data, analytic equations, and analytic equation in the form of explicit, implicit, and parametric. Now, a curve in general, for example, this is a curve. Now, this curve will be represented in the computer's graphics data by number of coordinate data. Say in this curve may contains 100 coordinates or 200 coordinates, whatever it is. You can store that data, and whenever you want to manipulate the graphics, you can use this data for transformation and you can do it. But this is a very difficult and more storage is more when you are using this type of coordinate data for curve representation. The other option is analytical equations. In the analytical equations, we have two types of equations. One is explicit way of representing the equations, curve equations, and implicit way of representing equations, parametric way of representing the equations. This explicit and implicit put together will be a non-parametric way of representing the analytical equations. Let us see what all is about. Now, for a curve, we need to have x, y, z. This is E3 Euclidean space. Now, in the explicit form, y is equal to f of x and z is equal to z of x. You can represent xyz relationship with the help of y is equal to f of x and z is equal to z of x. So, a point x, y, z will be x, f of x and z of x. So, this is the explicit form of representing the equation, analytical equation. Now, what is this implicit form? Implicit form, for example, a straight line can be defined as a combination of two planes. And it's two surface equations, one surface equation and another surface equation. These two equations, common point will be a straight line. So that will be implicit form of representing the equation. That means f of x, y, z is equal to 0 and z of x, y, z is equal to 0, and we'll get a common curve which is a combination of these two planes, two surfaces. This is the implicit way of representing a curve. So we have explicit way and implicit way, and this is also E3 Euclidean space. Now finally, the parametric way of representing the curve. Now this parametric way of representing curve, the variable u will be taken from 0 to 1. The u will be taken from 0 to 1. So you can select delta u as 1 by n. N may be any number, 10, 20 or 30, whatever it is. Whatever is required. For example, you want to have store 10 coordinate data of this curve. So here you can take 10. If you want to take 20 coordinate data of this curve, n is equal to 20. 100 coordinates of the curve, n is equal to 100, like that you can take. Now, this parametric way will be even space. That means only one space will be there, like xu, yu, and zu. So u will be varying from 0 to 1 for a number of points. Coordinates will get xu, yu, zu. So this is how there are three different ways you can use a curve in the computer. So the various curves that we will have are, the first point is the first one, Second one is line, circle, conics like ellipse, parabola, hyperbola, and these are all comes under analytical curves. And synthetic curves are there. They are cubic spline, Bezier, B-spline, etc. So analytical curves. So these curves can be represented in the three forms: one is explicit form, implicit form, and parametric form. In the explicit form, you will be having x, fx, gx, and in the implicit form, you will have two surface equations, and the common equation will be the corresponding curve. And in the parametric form, you will be having a u variable varying from 0 to 1, and depending on the number of coordinates you want to generate, you will be doing it in xu, yu, and zu by varying u 0 to 1. This is what I would like to discuss in the curves representation in computers. Thank you very much.